This video is going to look at the properties of our logarithmic functions, and here I have listed four of our properties, and I'm going to go through an example of each one of these. We have log base a of 1 equals 0. And the reason that this is equal to 0, because if we think about rewriting this in exponential form, I think it's easier to understand this particular property. So our base is a, so we can think of this as a to the 0 power, okay, a to the 0 power equals 1. And looking at this from an exponential standpoint, we know that anything raised to the 0 power is equal to 1. So that means the log of any base a of 1 will always be equal to 0. Okay. Then if we look at the next property, it says log base a of a equals 1. Well, that says we're going to take this base a raised to the power of 1 equals this a here. And I think a little bit that seems to make sense, because if a to the 1 equals a, then clearly the exponent over here has to be 1. Okay? And the next property here, where we have log base a of a to the x equals x, is very similar to this log base a of a. If we think of this property here, I'm going to take the base a, so this is log a here, raised to the exponent x. Okay, so that's saying here a to this power x is going to be equal to a to the x. Well, if that's the case, then if a to the x equals a to the x, then that means the exponent must be equal to x. Okay, and the other one, it's a little bit harder to see here, is the other part of this inverse property, and that's the reason these kind of cancel each other out. We have a to the log a of x equals x. So what's happening here? Let me go back to the first one here. If we have log base a of a to the x, you can almost think of when this base and this base matches up, then your answer over here is simply going to be this exponent. So you can kind of think of this as canceling out due to this inverse property. And over here with this second property where we have a to the log base a of x, the same thing is happening. If this base matches this base, then your answer is simply going to be whatever this number here is. So that's going to be x. All right, and then the last property is the one-to-one property, and this is very similar to the one that we looked at with our exponential functions. And of course here the bases have to be the same, and if that's the case, then if you're taking log of x and that's going to be equal to log of y, then I hope it's somewhat obvious that x must also be equal to y. So now I'm going to go through several examples of each one of these, and the first one I'm going to look at is log base a of 1 equals 0. So if, for example, if we want to simplify the following expressions, we have log base 7 of 1. Well, if I was to rewrite this, now we know that log base 7 of 1, based on this property, this should simply be equal to 0. Now let me rewrite this in exponential form and see if we can see that a little bit better. That means that we're taking the base of 7 raised to some exponent, and I'll call that y, some exponent, okay, equals 1. So if I think of it this way, if I think of setting this equal to y, then 7 to what exponent y equals 1? Well, clearly, if we're taking 7 to a power and we want to get 1, that means 7 to the 0 has to be equal to 1. Anything to the 0 power is 1. So therefore, the answer to this then would simply be this is equal to 0. So over here we have a similar problem. We have log base 9 of 1, and we want to know what does this equal. Well, once again, we're saying 9 to what power, 9 raised to what exponent is going to equal 1, and based on this property, we know the answer is going to be 0. 9 to the 0 power is 1. Now the last one here is natural log of 1. Now keep in mind, I know sometimes this is hard to realize, but remember this is really log base e of 1. So what that means is, again, natural log of 1, it doesn't matter. This is just another base. So don't think natural log is anything different. It's really no different than log base 9. The natural log just means it's log base e. So if we're taking the natural log of 1, the log base 9 of 1, or log base 7 of 1, based on this property, the answer is simply going to be 0. All right, if we look at the next property where we have log base a of a equals 1. Once again here, we're indicating if this matches this number here, you're going to be equal to 1. So if we look at log base 6 of 6, then we know that clearly this should be equal to 1. And to help see that a little better, let's rewrite this in exponential form. So that means we're going to take this base, 6 raised to the power of y, is going to be equal to 6. Okay, so if we rewrite this in exponential form, clearly we can see that if 6 to the y is equal to 6, then the exponent here must be equal to 1. Now, we don't have to go through this whole bit every time, because we know that if log base 6 of 6 matches up, then we simply know the answer is going to be 1. Just like over here, log base 23 of 23, these match up, so we know the answer is simply going to be 1, because 23 to the first power is going to equal 23. Now again, the last one, natural log of e. Keep in mind, this really is the same thing as log base e of e. Again, the bases match up, so e to what power equals e? And again, that's simply going to be equal to 1. All right, the next property here, we have log base a of a to the x equals x. So what we're looking at now is if this base and this base matches, the answer is going to be the exponent. So for this example here, log base 2 of 2 to the 4th, we know the answer should be 4. And again, if we were to rewrite this, that means we're going to take 2 to the exponent y equals 2 to the 4th. And if we write it in exponential form, it is clear to see that y must be equal to 4, because if 2 to the y equals 2 to the 4th, y equals 4. And again, this is going to happen anytime that this base and this base matches, then the answer is going to be the exponent 4. All right, the next property here we have is looking at the other inverse property, and that says that if we have this base and this base matches up, your answer is going to be the x here. So we have the same thing, a raised to the log base 8 of 3, 8 to the log base 8 of 3. So once again, this base and this base matches, so your answer is simply going to be 3. And the last one, we have a natural log e to the x. Once again, this is the same thing as log base e of e to the x. So that shows us that our bases are the same. So therefore, the answer is simply going to be the exponent, which is x. So again, it's kind of like the natural log and the e cancel out, and you're left with the exponent x. Just like the first problem, log base 2 of 2, that cancels and you're left with the exponent 4. All right, now we have our one-to-one property. If log base a of x equals log base a of y, then x equals y. Now this is going back to the exponential type problem we had before. If log base 5 of x equals log base 5 of 8, then I'm hoping that it's clear that if these two quantities are equal, then x must be equal to 8. Because if you're taking log base 5 of a number and that's going to equal to log base 5 of 8, you have to be taking the log base 5 of the same value, 8. So now the next equation over here, how do we solve log base 3 of 3x plus 2 equals log base 3 of 17? How do we solve this equation for x? Well, using the one-to-one property, we know that this quantity has to be equal to this quantity, so we can simply take 3x plus 2 and set that equal to 17. And if we solve for x, we're going to subtract 2, so 3x is equal to 15, then divide by 3, so x is equal to 5. And clearly, if we plug 5 in, we get 3 times 5 is 15 plus 2 is 17. So log 3 of 17 equals log 3 of 17. And then the same thing is going to be true if we're solving this equation where we have the natural log of x minus 4 equals the natural log of 3. Once again, this quantity must be equal to this quantity, so that means x minus 4 has to be equal to 3. And if we add 4 to both sides, we end up with x equals 7. All right, so there are some examples of all these different properties. And these are 4 properties or 5 properties here that you should memorize. And if you forget these, again, if you rewrite these in exponential form as I did here, I think it's clear to understand where these properties are coming from if you think of them in terms of an exponential form as opposed to logarithmic form.